Hello everyone, welcome to the Roots of Unity. My name is Soumya and today we'll learn about modulus functions. So what exactly are modulus functions, you might ask? Well, the two lines you see on your screen beside the -1, that is the modulus. So the modulus of -1 means the magnitude that -1 represents. The magnitude of -1 is 1. And obviously the modulus of 1 is also 1. So to help better visualize this, we can draw a number line with 0 in the middle. And here you see the distance -1 is apart from 0 is the same as the distance it is apart from 1. So they have the same magnitude and the same modulus value. Now if someone were to ask you for a random variable x, the modulus of x is equal to 1. What is the value of x? So x can be either 1 or -1. Both are applicable. Now let's take a look at a sample question. We have 2x minus 4, the modulus of which is equal to 10. So when trying to solve modulus questions, we have to consider both the negative answer and the positive answer. When you consider something's modulus, the negative or the positive sign does not matter. So first, considering the positive sign, we have 2x minus 4 is equal to 10, which equates into x is equal to 7. That's the first answer. Now we consider the negative answer. 2x minus 4 is equal to minus 10. So this one equates to x is equal to minus 3, and we have both our values for x. Now, if we try to think about this in a graph, if someone were to ask you to draw the graph of y is equal to 2x minus 4, you can simply draw a straight line using the intersections with the axis, and it would look something like this. Now, if someone were to ask you to draw the modulus of 2x minus 4, that would put you into trouble. So it's actually simple. It's actually pretty simple. You do the same exact thing. You draw the line without the modulus sign. You draw y is equal to 2x minus 4, but you exclude the negative part. You exclude the negative values for y and make them positive. So how to make them positive? We reflect the negative part on the x-axis, and there we have the modulus graph. Now to solve these modulus questions, we can use a simple trick. To use this trick, you first need to understand when you square something. When you square minus 4 or when you square 4, both of them give the same answer. Minus 4 square is 16, 4 square is also 16. So the sign does not matter. We are presented with the modulus of 3x minus 2 is equal to the modulus of x plus 4. So trying to solve this, we can use the trick. We square both sides. And what we have remaining is 2x squared minus 5x minus 3 is equal to 0, which is a simple quadratic equation you can solve using the middle term break. We get the answers of x is equal to 3 and x is equal to minus half. So modulus questions, there's another part. The main part of the modulus questions are the inequalities. Looking at this one, we have x minus 2, the modulus of which is less than 3. When trying to solve inequalities, you have to think about how to make the expression positive and how to make it negative. When does the expression become positive? When x is greater than or equal to 2, you can consider it as positive. And when it is less than 2, it is negative. So we consider two cases. We consider the first case of x is less than 2. What happens is the expression becomes negative. We have minus bracket x minus 2 is less than 3, which gives us x is greater than minus 1, which gives us a total range of minus 1 is less than x and x is less than 2. Now we consider the second case of x is greater than or equal to 2. What happens now is the expression is positive. So we have x minus 2 less than 3. Calculating this, we have x is less than 5, giving us a total range of x is greater than or equal to 2 and less than 5. Now we consider both of these total ranges and calculate the actual total range of x is greater than -1 and less than 5. Now we consider the case where in an inequality you have modulus expressions on both sides. We have x minus 3, the modulus of which is greater than or equal to the modulus of 2x minus 4. Trying to solve this, we have to do the same thing. We have to consider the boundaries, the ranges which cause the expressions to go positive or negative. For the left hand side, we have the ranges of x is less than 3 and x is greater than or equal to 3. For the right hand side, we have x is less than 2 and x is greater than or equal to 2. Now we take the largest range first. We take the largest range of x is greater than or equal to 2, greater than or equal to 3. As x is greater than or equal to 2 does not matter. X is greater than or equal to 3 is larger than that, so we take that. Now we take the lowest one. We take x is less than 2 rather than taking x is less than 3. We take the largest one for the greater than, we take the lowest one for the less than. So we write those down. We write both of the ranges down. X is less than 2 and x is greater than or equal to 3. And then we write the middle range. The middle range, the range between those two values of 2 and 3. So we have 3 cases here. We have 3 cases and we try to find the answer for all 3 cases. First comes x is less than 2. So when x is less than 2, both sides, both the left hand side and the right hand side, they are negative. So considering them negative, we equate the answer to be x is greater than or equal to 1, getting a range of x is greater than or equal to 1 and less than 2. Now we consider the second range, and for the second range, the left hand side is negative but the right hand side is not. So we have a different answer. We get the answer of x is less than or equal to 7 by 3. So we have x is greater than or equal to 2 and less than or equal to 7 by 3. Now for the third case, x is greater than or equal to 3. For the third case, both sides are positive. Both sides are positive. When x is greater than or equal to 3, x minus 3 is positive, so the modulus is positive. When x is greater than or equal to 3, 2x minus 4 is also positive. So considering both of them positive, we get x is less than or equal to 1. Now this is not possible because in the third case, x, we already mentioned that x must be greater than or equal to 3, so it can't possibly be less than 1. So this is not applicable and we ignore this case. We combine the first 2 cases and we see that the inequality is satisfied by x is greater than or equal to 1 and less than or equal to 7 by 3, taking the limits. Now you might say that I don't like this method. I don't like all the calculations. I want to do something bit different. Now I have a second method for you. A second method for all of these modulus questions, which is just draw a simple graph. Draw both of the sides. Draw the left hand side and the right hand side on a graph. So first we draw the x minus 3 side. When we try to draw a modulus graph, we have to take into consideration the intersections with the y-axis and the x-axis. For x minus 3, we have the intersections of y at 3 and x at 3. So taking those intersections, we draw the straight lines, and then we draw the second graph of 2x minus 4. Doing the same thing, we take the intersections with the axis and draw the second graph. Now we see that the 2 graphs intersect with each other. We have 2 intersection points. Between these 2 intersection points, y1 is greater than or equal to y2, which is what our original inequality asks, for x minus 3 to be greater than or equal to 2x minus 4. So between these 2 intersection points, this inequality is true. So we can find out the value of x and we see that the values are actually 1 and 7 by 3, as we found out by the answer of our previous method. And that concludes our video. Thank you so much for sticking with me, and we have completed all of the modulus function topics. Goodbye and have a great day.